All right. Good afternoon, everyone. This is Sulaim Khan with Texas Energy Engineering Services. We'll be going over the energy efficient lighting retrofit options today. And I want to thank everyone for joining this webinar. And I'll do my best to go over some of the fundamental things that you'll be running into if you're considering retrofit options. So we'll get going over here. So just want to remind everybody that this is the first seminar in the series of seminars that we'll be having, and we'll have some more seminars in July, later in July, and then August. We'll be going over energy accounting and benchmarking, Energy Star Portfolio Manager overview, preliminary energy assessment overview, and energy efficiency consideration for water and wastewater treatment plants. So just want to give everyone heads up that that's something that's coming down the line, and we look forward to you guys joining us on that too. Well, the basic question is, why retrofit? So, and you know, different people have different reasons, but most of them will be saying that we want to do an energy retrofit or lighting retrofit for energy savings, for maintenance and operation savings, and improve the quality of light. So generally, these will be the three objectives, basically, that people will be looking into, and those will be the reasons that you'll be potentially considering a lighting retrofit. Before we go too much into it, I just wanted to give you all just an overview of the energy code trends and how it has impacted you know, the lighting portion of it. So one of the things that you have to do when you're designing new schools or offices or any other buildings, basically, you're supposed to look at the energy code and look at what is the lighting power density that they allow you, and you have to design within that lighting power density, basically. So I just wanted to give you all a little trend to let you all know that back in 2000, when International Energy Conservation Code was enacted over there, the lighting power density, which is watts per square foot, which you see on this y-axis over here, was around about 1.5. So for general offices, commercial, schools, and universities, you were allowed to have 1.5 watts per square foot. You can definitely see the trend. So in 2003, the energy codes usually have a 2-3 year cycle. So in 2003, the International Energy Code was enacted or upgraded to 2003, and you can see over there that the requirements for watts per square foot are already reduced. Then you almost see a constant trend all the way up to 2009 Energy Code, and then in 2012. The school and universities part of it pretty much remained the same, but the office or the commercial offices, you can see there was a big drop over there. And currently, the state of Texas is on the 2015 Energy Code, and you can see a pretty dramatic drop in the watt per square foot allowed when you're designing new schools or offices, commercial spaces, basically. So you can generally see the trend of how you know, the energy code have been impacting the design and the layout of the lighting systems. So at this point in time, we will be doing a quick poll. So just bear with us. All right, so the first poll was how many is interested in your organization doing a lighting retrofit. Basically, it looks like 43% have already started installation, LED installations. 26% are very interested. 30% are interested, and basically, so it's 43% have already started some sort of an LED lighting installations. Again, 26% very interested, and 30% are interested. So that's good to know, and we'll cover most of your bases over here. So the first question you generally will be asking yourself is, where do I start the retrofit? So on the indoor lighting projects, mostly general lighting is predominantly fluorescents, which are T8 linear fluorescents. These are 4-foot, 3-foot, 4-foot, 6-foot, and 8-foot linear fluorescents, and then which is almost 80 or 90% of the lighting systems in general commercial buildings. Then you will see a high bay lighting system in gymnasiums and warehouses, which is predominantly high intensity discharge, and which is also the metal halide fixtures. And then a couple of years ago, a lot of people started converting them to linear fluorescence. So these were T5 high output kind of fixtures over there. So this is where you're looking at the lighting retrofit. That was the indoor. And the outdoor, predominantly you will find that most of your outdoor lighting is HID, and you will see security or wall packs, which is the picture up there, or something similar to that you will have. And you will also see pole lights, which predominantly are HIDs or metal halides. They could be 400 watts or 1,000 watts depending on the application. But you've seen a trend of people moving into LED lighting retrofits on those. Before we go too much into some of the things, I want to go over some terminologies so that you all have a general understanding of what are the things that you might be running into. And some of these things are relatively pretty important because when you're considering a lighting retrofit, having a general knowledge about some of this terminology is good to know, basically. So I'll be going over the T5, T8, and T12. What is a lighting efficacy? What is a color rendering index, which is also known as CRI? What is the color temperature? And what is the foot candles? And what is the ballast and LED driver? So we'll be covering some of those in the next few slides. So we have a poll up. Which property of lamp determines the warm or cool appearance of the light? So I have the results of that. Looks like 9% says the color rendering index, 57% say the color temperature, and 26% said both CRI and temperature, and 4% said none of the above. And the correct answer is the 57%, which is the color temperature. And we'll go into little details in a little while. Okay. Terminology. We're continuing with the terminology. I wanted to get, you have to have a feel of what is a T5, T8, and T12. So these are all linear fluorescents that you will see in your offices, your commercial spaces, and so on and so forth. So the T12 fixture or the lamp and the T8 lamps are basically the linear fluorescents. They are, you see them in a box because when if you all remember, around about 15-20 years ago, you used to have 40 watts T12s with magnetic ballast, and then there was a movement where they have low wattage, which was called the 34 watts and the 32 watt T12 lamps, and then these are pretty much out of the market now. T8s were the things to do at that point in time, and there is a substantial amount of T8s. Pretty much almost everywhere you're going to run into T8s right nowadays. So the T8s were the retrofits for the T12, basically. Now, some people have also used T5, which you see up there, which is the smallest lamp. These T5 were mostly used in high bay applications. Some people have used them in the offices and so on and so forth also, but not very common. And one thing to keep in mind is that if you got a T5, you couldn't actually use the T8 in the same socket as T5. So the sockets for the T8 and T12s are the same. The socket for T5s are a different size. So that's just something to keep in mind. And also the T5s actually cost more for one reason or another. The T8s actually initially had a higher cost, and then as the production increased, the cost went down, which is pretty similar to what is happening with LED lighting also. So very important to keep in mind is that these are the three type of different diameters fluorescent fixtures that you're going to run into. The other important thing that I want you all to be kind of aware of is the lighting efficacy, which is a measure of how well a light source produces visible light. And it's usually in a lumens per watt. So lumens is how much light is coming out of how much of wattage of energy it's using to take that light out. So basically, lighting efficacy is an important term that you just need to be familiar with. So that's lumen per watts. The other thing is the color rendering index, which is also known as CRI, which is primarily how accurate a light source makes the color of an object appear to human eyes in comparison to ideal or natural light. And it's measured from 0 to 100. So this is an important, the CRI is pretty important. And the next slide you will see, and hopefully the resolution on your screens is good enough, where you could see the differences in the way these things appear. So basically the CRI of 50, you won't be seeing the true colors. The CRI of 80 is where you pretty much are looking at things in much more clearly, or they appear much more clearly. The CRI of 90 is going to be way up high. So anything above a CRI of 80 is generally considered pretty good. So most of your LED lights, the fluorescent lights, you will have the CRI of 80, 85, somewhere in that neighborhood, basically. One other thing that you will run into, and this is a very important one, which is the color temperature. It describes how the light appears from the light source. So it's measured in Kelvin, also in abbreviation it's called K, usually between 2700 Kelvin and 6000 Kelvins are, you will find the lamps in those ranges basically. The less than 3000 Kelvin is a warm light, considered a warm light, and greater than 3500 K is considered a cool light. So this is something that's important, and I will just show it to you in the next slide, how or what to watch out for when you're ordering some of these lamps or when you're considering a retrofit. So again, important thing to remember is a warm versus cool, which will be reddish or yellowish versus bluish kind of light. So the cool light will be more bluish in kind of appearance, basically. So when you're doing this, you will find out that when you walk through a facility, you will you run into this all the time. And this picture, unfortunately, is from our office, in which one of the lamp is 41K. It has got a whiter appearance, basically, or a brighter appearance. Another one is a 35K, which has got a little yellowish kind of an appearance. So when you are ordering your lighting systems, it is very important to specify what color temperature you want the light to be, because a LED or a T8 would both come in different Kelvin ratings. So you just need to know that you want to have the 41K is predominantly what I've seen, but a lot of time the purchasing department would order equipment because they're all T8s, and by mistake they may put 35K over there. So you get a mixture of 41K and a 35K, which sometimes people have the appearance that we got older fixtures or we don't have a good quality light, basically. So this is something important to keep in mind. And then you see over there the color, light color, basically. So if you're on the 3000 or less, you'll be more yellowish or reddish in nature. The higher the Kelvin, the brighter it will look like. And then on the extreme right is almost 6000, close to 6000 Kelvin, which will be normally daylight. If you're looking at outside, that's what it would be. So the other important thing to keep in mind is mostly for office applications and so forth. Office applications and so forth, you will normally be the 41K or 4000 Kelvin range, but you may have special applications such as printing room or something that's require a higher Kelvin rating. So normally over there you will see a lighting system specified with 5000 Kelvin ratings. They cost a little bit more, but that will be in printing shops and so on and so forth. So that's the color temperature is very important, and I would like you all to keep that in mind. The other thing that is important to know is the foot candle. So what kind of foot candles do I have? You may have heard this terminology, which is a measure of light intensity, which is lumens per square foot. So I've just given you some examples over here. Typically in office spaces, open or private offices, the average or maintained foot candle on a horizontal plane is around about 40. So this is at a desk level, or which also wherever you'll be doing the task level, it's called. So average foot candle of 40. So there'll be places where you will have more or less foot candles, but on average, a 40 foot candle is what expected. In the classrooms also it is around about 40 foot candles, but they could be anywhere between 30 to 50, but as long as you have an average foot candle on a horizontal plane of 40, you're good. In corridors, you will see foot candles anywhere 20 to 25 range over there, and there might be occasions where you see 10 foot candles, 20 foot candles, 30 or 40 foot candles. You'll see a range over there. But normally a 20 plus or 20 to 25 foot candles is what you'll see in corridors. Open parking lots in urban areas, the average foot candle requirement is around about 1.5 foot candle, and you might see a range of 0.75 to 0.3 basically in a horizontal plane. The other area that normally in gymnasiums in a high school, if it's a non-UIL kind of a high school gymnasium, then you will see around about 50 foot candles is what is expected over there. However, there are specific requirements for UIL rated gymnasiums, which is around about 80 average foot candles over there. So if you have got a campus that has a UIL competition, you will normally need to raise your light level to close to 75 to 80 foot candles. Now, the gymnasium in the college, a class 1 pro or division 1, the average foot candle requirement in the horizontal plane is around about 125, so pretty significantly higher. I also want to let you all know that there is also certain requirements for certain areas, what they call the vertical foot candles basically. And the vertical foot candles will be important in gymnasiums so that you are able to see the object if it is thrown up high in the air. And it is also in warehouses, so you have to look at both of them, the horizontal foot candles and the vertical foot candles, because in the warehouses you may have aisles, and aisles may have different things stored in them, so you need to be able to see them. So I just wanted to give you all a general overlook of these foot candle requirements and just have an idea of what the targets are. Now, you all may have certain questions and so forth. You're more than welcome to actually ask them. We will be tabling them, and at the end of this session, we will answer any questions we have. And if we can't get to you, then we will definitely get back to you. So I just want to make sure that I mention that. I failed to mention it in the beginning. So the other thing, almost everybody knows this, but just want to make sure that the ballast, so all the fluorescent lamps or the metal halide will have some sort of a ballast, basically. So even if they were T12s, which are the older version of lamps, which are no longer available, they used to have magnetic ballast for them. Then came electronic ballast, and we've got electronic ballast nowadays. So the ballast is the one that provides the initial spike of voltage to turn the lamp on, and once it turns the lamp on, then it regulates the amount of current that goes to the lamp. So that's something that that everyone knows, but I thought I'd just mention it, and there's a reason for mentioning it, because when you go to LED lighting system, you will hear the term driver. So LED driver, basically, driver is almost the same, it has the same function as the ballast in fluorescent lamps. So you still need some sort of a driver in LED systems. So it is similar to ballast, except designed for LED lamps, converts high AC voltage, which is alternating current, into low DC voltage. It is more efficient. So normally the ballast actually has, they call a little ballast factor. So it usually have whatever the fixture wattage is, or lamp wattage is usually 10%. You can add the requirement for ballast. So if your fixtures, if your lamps in a fixtures are total 100 watts, with the ballast included, it will be close to 110 watts basically over there. But so the LED one are more efficient. They don't have the ballast factor into the equation basically, and can be external or internal. So what does that mean? So that means that you could have it external. The one you see in the picture on the left side is the external, almost look like a ballast, but is very lightweight and it's very small. And the newer version of the lamps are coming in that have, which you see on the right side, that have actually the driver installed in the lamp, and I'll go over that in a little bit, what the pros and cons of that is. So linear fluorescent retrofit options. What are the options for you to do energy efficiency project for a linear, if you have existing linear fluorescent retrofits? One option still is to do low wattage T8. So remember, they were T8s are 32 watts, then they started coming in 28 watts, then they start coming in 25 watts. So you could still do that, and there might be another iteration in which they will have lower wattage. So that is still an option, and some people are still doing that. The other option is that you could have LED tube lamps. So now they have almost like for like replacement. You can take the old fluorescent out and put an LED tube in there, and that will be using almost half the energy basically. The third option, and I have it in red because it is not very popular, and there is still some discussion on if that is an option that people would be doing in the future, or there are a lot of considerations in that. Initially, this option, the one in red, which is called the ballast bypass LED lamps. In other words, you have an LED lamp that has the integral driver is actually built in, and you don't need a ballast for that application. So that's something that's being worked on and continue to be improved, but still a lot of concerns with that application. The other option is the LED retrofit kits, in which you could have the LED lamps, and then you take the ballast out and you put the driver, basically the external driver, in there, and a lot of people have done that. The other option is you consider the whole fixture replacement. So not too many people do that, but some do that. If you got fixtures that are 25, 30 years old, it may be time, and they're not in good shape, it might be time to do the whole fixture retrofit, and you just replace it with LED fixtures. So these are the typical choices that you'll be running into, and I just wanted to briefly go over them, and then I'll go into more detail in each one of them. What are the pros and cons of each one of them? So the first one, the lower wattage T8s, which is replacing existing 32-watt T8 lamps with 28 or 25-watt T8 fluorescent lamps. So again, something that people have been doing there and continue to do. Basically, what are the pros of this thing? It utilizes existing fixtures and electronic ballast, so you don't have to necessarily change the ballast. You can have a ballast over there. The ballast normally lasts for 15 to 20 years, or some more than that. So if you can actually utilize using these lower wattage in there. And I just have one comment on that, and I'll show it to you in a little while. But these are low-cost option. The fluorescent lamps would cost around about $1.50 to $2.50 basically. So it is a low-cost option. You don't have this first initial cost over there, and so it's got a good payback. Although it doesn't have that much of energy saving, but it'll have good payback because the cost is low also. So what are the cons? So it has less energy savings compared to LED, and I'll show you a slide later on that does all the comparisons. Lamp life or lumen depreciation, that is something that is important to a lot of people. So they have a they have a little accelerated depreciation of lumens, which is the output of the brightness of the lamp as compared to LEDs. And by the way, ballast compatibility has still been a problem if you've got an older generation of electronic ballast, or first generation electronic ballast. 28 watts would normally work, but the 25-watt lamps had some problems with that. So in that case, you had to change the ballast with it. And the only way you can know is that when you put the lamp in there and you see it flickering or something like that, then you know it's time to change the ballast too. And it has a lower light output. So theoretically, it has got anywhere close to 5% less light output, but we have seen when you install even these low wattage lamps, you still might be within the IES standards for that area, and sometimes they are brighter because the old lamp that you had over there was already depreciated, so they had low lumens. So when you put new lamp in there, it is brighter basically. So a few things just to take consider. The other is LED tubes. So replace T8s if you got T8 fluorescent lamps with LED tubes. So this is almost like like-for-like replacement. The pros of this thing is use existing fixture and electronic ballast. So you don't have to change ballast, especially if they're a newer form of ballast within the last 10 years or so. But if they're, again, older first generation ballast, then you may have to replace the ballast with it. Lower wattage. Nowadays, they're coming in anywhere from 12 to 15 watts, equivalent to 28 or 32 watt lamp, basically. So definitely, almost half the wattage that a 32 watt would use. Longer lamp life, so these have been down about 50,000 hours, so pretty good life basically. And the good thing about these LED lamps is that it maintains its lumen for a long period of time, basically, so that's something to keep in mind. And the newer versions of these lamps are coming in where they could be they could be directly dimmable also, basically. So if you've got a dimming system, you could put these lamps in there, and you'll be able to dim it and so on and so forth. So these are the pros. The cons are the cost. So initial cost compared to the T8s is the lamp cost a little higher, and the ballast compatibility issue is something you need to watch out for. Now, something about the cost of these things, I just want to mention, and I was looking at my notes, and I could see basically that back in not that long ago, back in June of 2015, the LED lamp, just the lamp, cost around about $25 for a 17 watt, and it was a 17 watt output. In July, which is almost a year, of 2016, almost a year later, the lamp cost, LED lamp costs have dropped to close to $15 per lamp and was in the neighborhood of 15, 16 watts. So cost went down and the wattage is also going down. And I believe nowadays you can get them anywhere from $7, $8 to all the way to $10, $12 per lamp, and you can get them also in 12 watts and for between 12 and 16 watts. So you can see that almost in 1 year there's a substantial improvement in these LED lamps. And one thing to keep in mind is that there are continual improvements on these things, and they've got newer versions. That's why when you buy a lamp 6 months later on, they may say it's a generation 6, generation 7. So that's how they're keeping up with it. So something to just keep in mind. Retrofit options, ballast bypass LED. So what this is this is also LED. When you look at this lamp, you won't be able to tell the difference. It almost looks very similar to the regular LED tube lamp, or which is almost similar, looks very similar to the fluorescents, but they are direct wired. So in other words, they have got built-in driver in there, so theoretically you don't need a ballast or an external driver to run these things. So the pros of this one is, again, lower wattage. Ours are the same as standard LED lamp. No ballast, has integral driver. The cons are the higher initial labor cost than LED tubes due to extra wiring required. So if you want to retrofit your fixture, want to get rid of the ballast, you'll have to hire an electrician, because only electrician can do that. They will go and dismantle the ballast, rewire it, and make it ready for this type of an application. One thing you got to watch out for when you do this thing, not too many people are doing it, but there are some people who are experimenting and have some success. Some of these applications are now UL approved, but there's still a lot of concerns on this type of retrofit. So that's why you don't see it that common. And one of the concern is that now you don't have a ballast. So actually, when you are going to be doing long-term maintenance on this project, you almost have to, when you rewire it, you put this in the same socket, then you need to know which socket is hot wired. So there will be one socket that'll be hot wired, and always, so they'll have a 277 or 120, whatever voltage you have, will be coming to that socket directly. So that's something that you'll have to watch out for. And normally, the people are still working on the nomenclature and how to identify them and what will be the retrofit options and so on and so forth. Question. So the retrofit options, LED retrofit kit. So this is where you say that, oh, I want to get rid of the ballast. In that case, what you do is you'll have to have the driver installed over there. So it's replacing existing TH fluorescent lamps and ballast with LED lamps and LED drivers. So the advantage of this one is lower wattage, utilizes existing fixtures. It's in the same fixtures you do the retrofit. Reduction in maintenance costs due to longer lamp life. So basically, although we are showing 50,000 hours over there, basically, but a lot of time you can get almost $100,000 hours of warranty on it, because now you have replaced the whole system, basically. So they'll give you longer warranty on this thing. No ballast required, but just keep in mind, although you don't have a ballast, but your driver is the ballast, if you can think in those terms. The cost more than fluorescent plug and play. We call them plug and play, in which you take the old lamp out, put a new one in. The reason it costs more is that you have to rewire it. You have to take the ballast out. You have to have an electrician doing a lot of this stuff. So it costs more. Than first cost and installation cost is more. That's something to keep in mind. So retrofit option, the full fixture retrofit option. So you have another option in which you can actually go and change the whole fixture. Some school districts have done that. Basically, some offices have done that. Some cities have done that. Local government have looked into that, this portion of it. So you are looking at replacing existing fixture with new LED fixture. So you're taking the whole fixture out and you're putting the new one in, and it is an LED fixture. The advantages or pros of this one is you normally will have more energy savings by doing this retrofit. Integrated controls, so you could have motion sensors and dimming controls as part of these things. The longest life, this will have over 100,000 hours of life on this thing, so you will have a longer warranty on this stuff, and variety of design options and considerations. So there are a lot of ways that you could go do the modifications, but just keep in mind that any options that you like to add, for example, you want to make it a low voltage kind of a wiring system, would be able to dim and do different things with it. So what is happening is that now they come with little controllers, these fixtures, and then they have to program them, and then it gives you the option of doing different things. So there are a lot of options, cost associated with, just keep that in mind. The cost is higher because it's a whole fixture replacement, so typically it will cost a little more and will have longer payback. Savings comparison. So I thought we put something on a table form and just show you these different options that we talked about. One of the things you will see that I did not include in there, the direct the lamp with the built-in driver in there. I have not seen a whole lot of these applications. We were a little reluctant in doing that, and there is some reluctance on the part of the owners in doing that, but there are some people experimenting with it, and they're making improvements. But all those aside, all these other options I've got direct experience with, so I can talk more definitely about them. So the lower wattage T8 lamps is the lowest cost. You will get energy savings per fixtures anywhere from 12 to 22%. The estimated life of these lamps will be around about 25,000 hours. Now, there's an asterisk with it, because what has happened is that as the LED market start flooding in and gain traction, a lot of fluorescent manufacturers actually raise their warranty period, so they also have close to 50,000. If you talk to them, they don't publish it, but you can get almost 50,000 hours of operations from them. So that's something to keep in mind. And now these are compared, the savings are being compared to from 32-watt T8s, basically. Okay, so the first one is a 32-watt T8. The estimate payback basically is between 7 and 8 years. So in other words, you are looking at changing lower wattage lamps basically, and your payback will be 7 to 8 years. And one thing to keep in mind is this is relatively higher payback because almost we have considered a little bit of ballast replacement cost in there. So normally if you're considering this kind of a retrofit, it is a strong recommendation that you allocate some contingency funds for ballast replacement, because you will be needing it. So normally, you know, you can consider that anywhere from 10 to 20% of the ballast you may have to upgrade. Now the payback is the initial cost divided by savings. So what was the cost of that retrofit, and what are the estimated savings from that retrofit? So the 7 to 8 years is for low wattage T8 fluorescents, basically. So LED plug and play, we got to watch out the word plug and play. It seems that it's just you take the old one out and put the new one in, but I'll go over certain scenarios and what thing to watch out for even when you're considering that simple retrofit. So they have low cost, relatively low cost, as I mentioned, that they went all the way in 2014, 14, they were not even an option. Round about in 2015, they stopped start at $20–25 a lamp, and now they're down to almost $10 plus minus a lamp over there. So you got more savings, 40 to 50%. You get a range, that range of savings. Estimated life is now 50,000 hours. That's how it's rated basically, and you got a payback on this investment between 5 to 7 years basically. So something to keep in mind, that you know, the payback ranges are different. Now, why are the payback ranges different? I think that's one of the questions somebody posed. The payback are different because each, you know, it depends on the operating hour and the cost of installation. So those are the two things that you got to watch out. So somewhere where you got lower operating hours, you will have longer payback basically. For the same cost as somewhere else where they got longer operating hours, they will have lower payback. So that's why you see a range of these paybacks, and that's why it's good to do an initial kind of assessment of these things to make sure that you're looking at the payback ranges and the application hours of operations and so on and so forth. The LED kits, which some people were doing, they were pretty popular 2 years ago, and some people are still doing it. It's their preference. They want to get rid of the ballast. It costs a little bit more. You'll get almost similar savings to just a plug-and-play tube replacement, same kind of hours out of it, and since it's cost a little bit more, the payback range is a little higher, so higher payback for that thing. And if you're considering a full fixture retrofit, basically, in other words, you take the old 32-watt T8 lamp fixture out and put an LED one in there, then that will be the highest cost over there, because now you're paying for the full fixture cost and installation, but you will also have more savings, 50 to 60% savings, and you will have longer life of lighting over there, almost 100,000 hours, and the payback is longer because the cost of these things. Now, as the cost keeps on dropping, the paybacks keeps on getting better and better. So I just wanted you all to look at these things, have this consideration basically when you're looking at your lighting retrofit options. So one of the other things I wanted to briefly touch base with you, we actually did a little test, design calculations what we were supposed to do. So this is an actual test case in which we looked at a room that is close to 32 by 24 feet, and it's a 9-foot ceiling, and we were looking at the task plane level from the ground, basically at what is the lumens per watt on a task plane. So what you see on the left hand side over there is the lumens per watt. Okay, so how much of light you get from the energy that you're using to get that light basically. So the 28-watt T8s has got, I will say, close to 62 lumens per watt. The 25-watt T8s has got close to probably 75 lumens per watt, and the LED is almost close to 99 lumen per watt for this application when we were looking at. So what it means is that you could be potentially using less fixtures when you're doing LEDs, but you've got other considerations of, you know, you can only place these fixtures at certain distances because of the room cavity ratio. Those are design considerations. So sometimes you're kind of restricted with that. One very important thing to keep in mind is that the lumen output in an LED fixture or a lamp is all dependent on the type of the drivers over there. Okay, so that's very important. This is something different than what when you used to have ballast over there. So actually you can specify different type of drivers basically that will drive that lamps to produce certain lumen output. And normally you know, there's a cost difference between going from one ballast to the next ballast over there, or from one fixture to the next fixture, or, you know, there are a lot of options over there. The good thing about LEDs is that, you know, people like it. It's a softer light, basically, and you got a lot of options. The bad thing about LED is, if you call it a bad thing, is that a lot of electronics are introduced in the lamps now, basically, right? So you got lots of options, and sometimes keeping up with those options is hard. So You could have fixtures basically that came out today, and 6 months or a year down the road, actually 6 months, they will have a new generation of that fixture which will have some additional features. You know, just like your computers, you've got better RAM, better different qualities over there. So that's what's happening with the LED fixtures also. That's because the induction of software and induction of these microprocessors into the lamps basically. So the other application is the high bay lighting application. Why replace traditional HID lamps? You know, so they usually you will have HIDs in there, which is high intensity discharge lamp. Anybody who's installed them knows that once they're turned on, they stay on all day long, because if you turn them off, it takes them 10 to 15 minutes to warm them up and to get the same light levels you had before. So as a result of that, you will see them on all day. They use higher wattage and they also generate a lot of heat. So the high bay lighting retrofit options would be fluorescent retrofits. You probably have seen that. That was the thing to do around about 3-4 years ago, and still is viable for a lot of people, in which you could use T5 fluorescent fixtures over there, and you could also use T8 fluorescent fixtures, and I'll touch base on that a little bit later. But you had the option to do T5 or T8 in a high bay application. LED retrofit HID to LED bulb change out. So there is also option where you have the LED fixture or HID fixture, and you can just take the lamp out and put an LED bulb in there. Some people have different results as a result of that. So it's something, if you want to actually test it before you order a couple of hundred of these lamps to replace in your gymnasiums and so on and so forth. So that will be the HID to LED bulb option. So the considerations are that, and also you need to consider if your existing ballast in that HID lamp is a fixture is old, then you will have a lot of problems with it, and then you'll have to change that ballast anyway. So it might be better to do it at one time, go change the whole fixture, because it costs a lot of money to get up there and do those retrofits. So the fixture retrofit is traditionally is coming out pretty good. You have a lot of options over there. So if you've got older HIDs in those fixtures, basically the best thing to do is to do a fixture retrofit. So this is something I just want to show you all. Basically, you can see on the left side there was a fixture. This was a place right here. The left side is HID, and the right side is LED application. You can see a day and night difference, and you can also see you got a pretty level lighting on the right side. So something I just want you all to look at it, that there's a drastic difference between the fixtures. The other options, or the high bay saving comparison, we want to look at. So I want to give you quickly a feedback on that. So the T8 fluorescent, so you could put T8s in high bay also. They were low cost. You could have 60 to 70% savings, 6 to 8 years payback. So a lot of people didn't realize that. They started putting T5s over there. Although they could use a T8 also, they might have needed another lamp or so, or have high output, but still with more savings, 6 to 8 years of saving. T5 will have a medium initial cost. It's a pretty, costs more than the T8s. Your 30 to 40% savings, 25,000 hours of operations, 11 to 16 year payback. The LED has got higher cost, and then the cost will be coming down 65 to 80% of energy savings, so significant savings. And then you've got 100,000 hours, and then the payback is still longer because of the fixtures still cost a little bit more, basically. Well, so the outdoor lighting, these are just, I put some photos of outdoor lighting that you'll see the parking lot and the security lot. So there are different varieties of outdoor lights that you will come across. So what are the savings for the outdoor lighting fixtures? So the LED, which we call the security packs, which are the wall packs, have got almost 75 to 85% of savings, 100,000 hours of estimated life, estimated payback of 6 to 8 years. So significant savings over there. You have 70 or 100 watt a metal halide, you can put a 20 or 15 or 20 watt LED in there and it will give you the same light, in fact better light output. And in the parking lot, pole lighting, you could go to LED options. You do the whole fixture retrofit. There are people who are looking into doing some retrofit within the existing fixtures, but the better option is to just look at the whole fixture retrofit, and you'll have 12 to 15 years of payback. So some of the things that you need to consider in retrofit is you must do pre and post foot candles. So what were the foot candles before? What is the foot candles after? That's good for your record keeping in case there's a question. You got to look at ballast compatibility. Some of them you just have to experiment. You change the light, the lamps over there, and then if they're running the problem, that typically means you don't have a compatible ballast. The cost to determine that beforehand is significantly higher, so your chances are you start the retrofit and then you deal with it as it comes on. First time installation, you got to be careful because a lot of time if you put the LED lamp in the reverse position, you won't be able to tell, so you won't be able to get the light output that you need from it. They have some issues with compatibility issues with the emergency fixtures. So you've got a battery pack or emergency fixtures in your facilities. You need to test them and make sure that you don't have a compatibility issues. Either you can leave the fluorescent in those fixtures, or nowadays they also we found out that the dimming, the LED lamps that are dimmable can be used in those applications, and they are also UL rated for those things. The color rendering index and color temperature is very important. We talked about it earlier on, so you need to make sure that you specify these and make it a standard. Recycling of lamps will be required. If you are a small facility, probably not, but if you're a small school, you become a small quantity generator, so it's better to recycle the old T8 lamps that you get out of these facilities. Project management and accounting is almost as important as the specifications, and the design portion of it maybe 20 to 30% of the effort. Almost 70% of the effort is managing this project because of the nature of the retrofits. It's just hard to keep up with the changes and account for all the changes. And if you got ballast at the end of your useful life, then you want to change the you want to change the ballast, or you want to go to one of the other options that we have. You also need to be looking into socket conditions, which is also known as tombstones. So you need to have some funds allocated for, if you're changing within the existing fixture, to be able to change the tombstones if they were old or bad shape. And then there are a lot of end users applications. So if you're thinking of doing dimmable and so on and so forth, you just need to take into account that you might have to do some additional wiring and rewiring to get those options that might be available. And very important is that you document the warranty. So these things are, LED lamps are now under warranty for 3 years if you're doing like-for-like replacement. But if you got a fixture, then and you're doing a new ballast and LED lamps, they give you warranty of 5 years plus. So just to keep in mind, and the fixtures are normally under warranty for 7 years or so. So some considerations, these are the considerations that you need to take into account when you're looking at this thing. I just wanted to spend quick 2 to 3 minutes on an actual case study. This is actually a project that just got finished. It was a United Independent School District in Laredo, Texas. They went to the State Energy Office Lone Star funds, applied for $7.5 million worth of loan for energy efficiency retrofits, and a payback of 8.3 years. Part of the project was they had a district-wide lighting upgrades, interior and exterior. The cost of those upgrades was around about $5.5 million. These are close to 45, 46 facilities, so pretty significant, close to 4 million square feet or so. Other measures were considered. They part of this loan from Lone Star, from SECO. They had chiller upgrades at one of the campuses. They had some power factor improvements in a couple of campuses, and they did the commissioning of 2 high schools for energy efficiency, which was HVAC and Controls Commission. The project just got completed in 2017. It was under budget, and it received maximum rebate from the utility also, basically. something to keep in mind. The district-wide lighting upgrades, the initial plan over there was to have low wattage TA. Now this started close to 2014 time frame. Remember that LEDs were not a good option at that point in time, or they were expensive. So the design phase, when we got to the design phase, at that time the LED options were evaluated again, and the district decided to do a test case because LEDs were still new. So they had a test case in which they got occupant inputs and then reviewed the installation for almost 1 or 2 months time frame, and we did some pre and post foot candles and so on and so forth. And then once we were pretty confident, we applied, or United ISD applied to SECO and did a scope change in which they requested that instead of doing low wattage T8s, we are going to do LEDs basically for interior. And the scope change went to the SECO review process, and then it was awarded. The contractor for this project was selected competitive bid process. There was significant cost savings between the low bidder and high bidder, so the low qualified bidder was selected. As a result, we were left with some funds savings over there, which were actually used to put all new LED fixtures in all the high schools and the middle school. And the beauty of this is that they were 2 or 3 locations in which they didn't meet the UIL light levels. As a result of this project, we were able to save them money and at the same time increase the light output over there also. So so this is something that you will see over here. You will see that we don't, this is one of the example. So on the left side is the one with the fluorescent. I don't know how good your resolution is, and on the right side is the one that that an LED retrofit was put in there. So something, and what happened was they let the students, teachers, and administrators go look at it, and almost everyone decided that they want to be in the classroom that's on the right-hand side, which was the LED retrofit one. So one very important thing, and I just want to quickly go over this thing. When these designs were done, there was some, we did a pre-installation foot candles, then soon after the installation there were foot candles, and then it was UISD required the contractor to have a certified lighting kind of a thing with the foot candles over there. So you would see a significant changes. There were significant changes in the foot candles. A lot of these, this facility was close to 20 to 25 foot candles, and after this LED light on retrofit, they were close to 40, 50 foot candles over there. So significant improvement over there, and got very, very good reviews basically. Sorry, it went back. And then these were also pre and post foot candles, very important. So in the library areas, these were LED retrofits, with which lamp retrofits, and in some cases were ballast were required to be upgraded also. And you can see almost universally that there was an increase in the foot candles, and some of that could be attributed to the fact that the existing fixtures were nearing the end of their useful life, so they were at lower lumen outputs also, basically, right? So, but you can see over there was significant improvement in the foot candles over there. Now, these are just some photos and photos of the installation. You see the one in the bottom left was LED lighting retrofit for the loop and the parking lots, and then some classrooms, and then and gymnasiums, and so very significant improvements, significant energy savings. Overall, a very good project that just got completed, basically, and they also received a lot of rebates from the local utility. Well, we are nearing the end, and I believe we have a couple of questions that I would like to answer. So the question was asked that would this presentation be available? Yes, it will be available. We'll also be recording that, and it will be in a PDF, and we'll be distributing to all the participants of this this webinar. So you'll be getting an email with the PDF of the presentation. The other question. Okay, so interesting question. It says in the early slide you showed the decreasing intensity requirement with the various energy codes. Does the decrease in watt requirement relate to the fact that the new lighting technology is more efficient, therefore needing less wattage to produce the same light intensity? Correct. Yes, significant improvements, and I suspect in the next round of energy codes, the lighting watt density will even be further down because the technology has actually gone way ahead than where it used to be, basically. And I believe these were the 2 or 3 of questions that we had. You can still have some questions, and you can always email them to us. Again, another question was, would we have, another question is there any floodlights of 1000 watt metal halide equivalent to LEDs? The answer is yes. So the question was, are there 1000 watts metal halide equivalent LED available? And the answer is yes, there are. And again, continuous improvement going in this area. And then another question is, I found a couple of LED tubes where the return on investment was under 4 years. So seeing some of these figures with ROIs 8 to 12 years is a little surprising. Yeah, good question. So, so the ROI has, it depends on how you look at it. What the ROIs that we're giving you actually is the cost of actually doing the retrofits. It's got labor and material involved in it. So there is a labor cost involved in it. It's not just the lamp cost, basically. So that's something to keep in mind. If you intend to do it with your own labor, then you will have a shorter payback. I think these are all the questions I have, as I'll take the opportunity to thank everyone for attending this webinar. We went a little bit over. Apologize for that. Again, my contact information is there, and I also have Stephen Ross's contact information, who's the SECO program manager for schools and local government program. Again, thank you everybody for attending this seminar, and have a good day. Thank you.